All right, so we're going to do a little late night streaming here. We're going to try to add in spirit regularization. And I think I found a way to do it without like any super dirty tricks. The dirty trick I was thinking of using was constructing strings and then using MATLAB's eval. But I think we're going to be able to do this without doing that. So first thing we're going to do is copy find W into recon spirit reg new. Which is here, okay. Now we're going to use find W. Now, I don't, I clearly don't remember what gets used where. I guess I'll make W here. Okay, we're not going to use gamma. We're not using gamma. Here's apply W. So now I remember thinking we're going to create all the functions, even the ones we're not going to use. Since we don't have lambda, we don't have to worry about that. The only issue is, does this work when op is not supplied? I don't think it does, so we're going to use this one instead. Let's add that into do checks. All right, let's see if we made W minus I correctly or not. Looks like not. Now that's interesting. Before we were always doing spirit regularization. So if you didn't pass in a gamma, that meant we would make it for you. But with this code, the idea is that, you're going to get to just select which regularizations you do. Like you might just do this one with the support without doing spirit regularization. So how do I know? How do I know if somebody wants to do spirit regularization or not? The simplest way is just to have a flag. Do spirit regularization. This one is if you supply the noise bound and you supply a support, right? The size of the ACR. And of course the W size. Okay, if you supply W size, that means you're doing spirit regularization. Do we use the ACR for anything else? Right now the ACR is just used for spirit regularization. The size of the ACR. Now the S maps we're definitely using right now. Okay. I have a feeling we're going to use the ACR for other stuff at some point. So for now, if you supply W size, then you're doing spirit regularization. Seems reasonable. Why would you use... Okay. Is this going to use something I don't have? Can't flip W without W. We'll only do these checks if we've got a W. Let's see how this goes. Right, we're calling everything wrong now. Expected a string, scalar, or character vector name for the parameter name. Where is that? Line 58. Oh, I changed it in 2, but not in 1. Okay. This in the end will be a very difficult function to test because we're going to have to test out each problem that we've created. And because of combinatorics, it's going to be a lot. Not impossible, and we'll do it. Let's see if it runs. Okay. We got as far as do checks. Why didn't we go in there? Noise bound is not supplied. Noise bound is supplied. Oh, I see. Because noise bound supplied, we don't check MFSPT. I think we check MFS anyways, right? There's a do check FS, MFS. I guess there's no reason to have these in different locations because we're not returning early anymore. So might as well have all the checks together. Do we have a check for P? No. We just check MFSPT. Let's check P here. There is no apply PT. Is there over here? No? Okay. Let's run checks. My daughter's sleeping in the other room, which is why I'm being a little quiet. If I leave in a hurry, it's because she wants something. I hope she's sleeping soundly. Okay. W and W minus I both passed. Now, we're still setting this manually. I'll deal with that at some point soon, probably tomorrow. But for just now, okay, we've got this gamma now. What on earth is gamma used? Min over the sphere. Okay. Function out equals G spirit reg X. And what is that? Okay, so this is the first G support H. Can I do this? I can. Okay, what is spirit regularization? Let's look at min over the sphere. Ooh. This is the one that we're doing, right? This was just data consistency. G2. This is G spirit reg here. Okay. G support. G support H is this. If none of max gammas, oh, if none L gamma is greater than 0, then G support H is equal to that. Why did I do it this way? G support H might be unused. Oh, G spirit reg H. So this is the function handle, which is why I'm ending it with capital H. The support's a little more complicated in terms of how to handle it, because in one case it gets embedded into the data consistency term and you can solve it with LSQR, whereas in the other case it doesn't. How am I handling that? I forget already. Okay, there is an LSQR at the bottom here. Okay, so now G is equal to G support H plus G spirit reg H. And prox G spirit reg H. This might be empty. And I'm hoping that just works. So what's the proximal operator of G2? Here it is. Call this norm coil X. Oh, I bet you can't concatenate function handles like that, can you? That'd be a miracle if you could do that. Now I'm wondering if I'm going to have to go back to the dirty trick of making strings and then evaluating them. Prox spirit reg. Oh, prox G spirit reg. See, that one's got. The functions G you just add together. But the proximal operators you concatenate. Ooh. That's maybe what I wanted, actually. It's not empty. It's an anonymous function that returns empty. I wonder if that works. I'll bet you it does. Okay. Let's pass in a W size. Looks like we're already doing that. Plus is not supported. Huh. You cannot add function handles together. What is, but G support H is empty. Oh, I had that. I could do that. Or just prox G support H. Does that work? Nope. Area uses vertcat. Non-scalar arrays of function handles are not allowed. Use cell arrays instead. I don't think you're getting what I'm throwing down here, buddy. Okay, this just got a lot harder. I'm making terrible mistakes. Okay, let's go back to the way it was, yeah? The separable sum rule for proximal operators assumes that the inputs into each of these are distinct. And that, of course, is what happens because there are different parts of A. Like the first part of A might do the data consistency, and the second part of A might do the support region, and the third part of A might do the spirit regularization. So it's like we've got in 1, in 2, in 3, etc. And then G support H1, G support H2, like that. And what I was hoping was that if this were empty, it just wouldn't return anything. It turns out you can't add function handles together. So G and prox G have to change based on the constraints that are being applied. So I think this crashes. It like does whatever. MATLAB reviews the code and doesn't throw an error, but it crashes because you can't add function handles. And this just didn't make any sense. This was me being silly. I'm a little confused about this. All right, just looking at F, if a noise bound greater than 0 is supplied, we have F grad. But then what is F? Oh, I see. No, I don't. How could F possibly be greater than 0 here? Oh, because F gets redefined there. This noise bound is intended just to be used for the support. But actually, if you have a noise bound, you can use it for the data consistency too, which is why I'm confused right now. But you would only want to do that if you had something else to minimize, like compressed sensing. Otherwise, you want to minimize this. So, okay, for right now, this is the right thing to do. I understand. This is, G is actually, well, forget what I was just going to say. So in this case, if numL support is greater than 0 and numL W size is greater than 0, I can define G and prox here. Else if numL support is greater than 0, G is equal to G support H. Else G is equal to G, else if numL W size is greater than 0, G is equal to G spirit reg H. And right? Now the question is what to do here. And that's not super easy because what you need is like G of n is equal to G support H of n from 1 to n in support H plus G spirit reg H n support H plus 1 to end. Or n in support H. And this should really be to n in spirit reg. We're going to have to do this for every combination of constraints. I'm very certain there's an easier way to do this in C. But we're not in C. And I can't think of an easier way to do this in MATLAB. It's going to be a hard code to maintain, I tell you what. If you want to add one more feature, you have to remember how to do all this. Handle all the optimizations. And you have to know which portion of n to call each regularization. All right, so what is n support H and in support H? Is there an n image somewhere? No? Yes? Look at that. Okay. What's the problem there? Might be unused? I use it right there. There's a bug somewhere. 314. $238. Oh, I see. Okay. Okay. I was defining n support H within this function, but this function, doesn't necessarily get called, and so it wanted this defined ahead of time. Now there's no issue, right? Right. What is n in spirit reg? So I could just put end here, but I'm going to need to know this when we start adding additional constraints. G spirit reg equal to nk data. Does such a thing exist? Nope. Okay. Just trying to find a fancy way to do this so we don't have this giant if statement handling all the combinatorics. But as of right now, I don't know how to do that. Think that runs? Nope. Symbolic math toolbox? In. I have, oh. Variable undefined prox g. Really? Okay. Prox g is equal to at in prox g support h from 1 to support h prox g spirit reg h Think that works? Nope. H of x. Let's find out what that is. H of x is g. All right. So first we're going to go to g support. So what is n in support? So n is just 256 by 256. Okay, I'm a little confused. Was I wrong? Vista solves f of x plus, or g of x plus h of x. Said differently, f of x plus g of x, right? You call the proximal operator y minus t dg. And y has the same size as x. Oh. G Spirit Reg. It's an indicator function for this. Notice you got to do FS. Here's an issue because we don't do PT. Do we? So how is that handled over here? G2. Where's G2? Okay, there was this efficiency where we were doing like FS once or something. I think maybe that's what happened. I don't know. Oh no, FS is in apply A, of course. So we have to change apply A too. So for each combination, we got to set G, prox G, and apply H. To stop this confusion, I could at some point rename F here to G and G to H, but I think we call everything with PDHG F and G, so it's just the way it is. PDHG minimizes F plus G of AX, and Vista minimizes G of X plus H of X. That's how things are right now. Okay, so can Vista solve this problem that I'm trying to solve now? I think the answer is no. I think we're going to worry more about that tomorrow. All right, I'll see you guys bright and early.